All right, so here in the bell work, I don't really have a defined bell work here. We're actually going to look at some homework problems on that homework packet. So if you turn to your packet, page 3, I'm going to work out problem 7. So if you weren't here Friday, definitely check out that video, but I'm going to do an extra problem here to help you guys out. So this is from the homework packet number 7. And it's a problem where you have to complete the square. So last time we talked about solving quadratics, we learned the method completing the square, which is saying that I'm going to try to take this quadratic equation and make it into a perfect square. So two factors that are squared. So if we are completing the square, what we want to do first is get rid of the constant. So the reason why you get rid of the constant is because most of the times a quadratic that is not factorable, you won't be able to, so let's say that 57, you can't get the factors to help you factor this out, then you can toss this to the other side to force this to be a factorable trinomial. So I'll start by subtracting the 57 off. So that cancels. And then I'm going to bring down the x squared minus 4x. And because you've gotten rid of the constant, I'm going to make a blank space for my new constant to put my c, or my constant. So negative 5 minus 57, that combines to give you negative 62. And then I'm going to put another blank space on this side, so that way I can add in my constant, my new constant. That will help me factor. So in order to force this to be factorable, right, we take our b value. In this case, our b here is negative 4, the number in front of x to the first power. So take b divided by 2, so negative 4 divided by 2 gives me negative 2. So in this case, when I factor, I have x minus 2 and x minus 2. So when you divide by 2, this number goes to both of the factors. This helps me figure out what c is. Notice how when you take negative 2 and you add it to negative 2, you get the middle number, right? Negative 2 added with negative 2 gives you negative 4. When you multiply these two, you get positive 4. And so I have to add 4 to both sides, hence why I have this blank space here to remember to add it to both sides. Now this side here, if I combine these two terms, I get negative 62 plus 4, which is negative 58. And it looks like that's all I can simplify on this side. Now this side here, remember there are two factors, so you don't have to write it as two factors. You can write it as x minus 2 squared. And then to get rid of this square, I would have to take the square root. So to get rid of squares, we take the square root of them to cancel. And when I do this, remember the goal is to get x by itself. So x and minus 2 comes down. I have to take the square root of 58. Let's check out if we can take the square root of 58. So 58 can be broken down as 29 times 2, right? And 2 here can't be broken down. Neither can 29. 29 is a prime number. So whenever they're both a prime number and you don't have identical prime numbers here, you have to throw it back inside the root. So this is still going to be the square root of 58. Now, I do spot a negative sign here, right? Since this is a negative, that means this is an imaginary number. So I'm going to put an I next to it. And because you've taken a square root, you need a plus and a minus sign in front of the square root. So from here, I have my I have the square root and a plus minus. I need to move over this 2 here. So I'm going to add 2 to both sides. So that cancels. Let me shrink this down just a bit. So if I cancel that, x is now by itself. And then when I add this 2 over, because I notice it's the real number, I'm going to put that in front. And then I'll put my imaginary number on the right side. And like I said last time, this is really just a preference, okay? So this here is my final answer because x is by itself. I also want to remind you guys, this I is always outside the root, okay? This I should never be inside the root. It's always outside. Whether that be on the right-hand side or in front of the root, it doesn't matter as long as it's outside the root and attached to that term, okay? All right, so let's walk into our Journal 26 and look at what today is about. Okay, so we are today learning the fourth method for solving a quadratic equation. So our fourth method here is called the quadratic formula. Okay, the quadratic formula basically allows you to solve any type of quadratic that you have, which is really nice. But here's the only terms or only caveat for using the quadratic formula. Number one is that it needs to be in standard form. Okay, it needs to be in standard form to use. The other thing is that the right-hand side, or at least one of the side, needs to be a 0, meaning that everything, all the terms should be on like the left-hand side, whereas one side needs to be 0. So if there were anything on this side, you need to push it to the other side. And then from there, this formula basically uses the coefficients that are in front of the x squared, the x, and the constant. Notice how you're plugging a into the square root and the one in the denominator, b in the outside and the inside of the root, and c on the inside of the root. So as long as you know what a and b and c is, you plug it in, simplify the formula, and then you'll get to your x values. So this is saying you can solve for x using this formula, and you don't have to do any guesswork on like, oh, let me figure out what number multiplies for c and adds to give you b. Whereas like when you were factoring, you had to like think about what numbers could work. This formula, you just plug and you just simplify. So there's a way you can remember this formula. Keep in mind, I will not give this formula to you on the test. You will need to know it. But this is one of the only formulas you really need to know for the test. All right, let's take a look at an example problem of this. So here I have an example of a quadratic formula, and it's here that it's almost in standard form, but I need to move something over, and it's the 7. So this right-hand side is not a 0 yet, but I need to make it a 0. So I'm going to subtract 7 to both sides, and that cancels, bringing down the 4x squared, the positive 3x, and the minus 7. And now this side is 0. Once this side is 0 here, you can figure out what your a is, your b, and your c. So a here is going to be 4. It's a number in front of x squared. B here will be positive 3. C here is going to be negative 7. So if there's a minus sign in front, make sure you make it a negative. Okay, so I'm just going to write down the quadratic formula here to the side so I can get ready to use. So I have this jingle to help me remember the quadratic formula, and you can use it too. If you know the song Pop Goes the Weasel, it goes in the tune of Pop Goes the Weasel. So it's a very quick jingle. So it goes like this. X equals negative b plus or minus the square root. B squared minus 4ac all over 2a. So let me kind of sing that a little bit faster. So basically it goes x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And so I usually will, like, if I forget, I sing this song and I just can remember what is in this formula. And I've been using this for years. And if you're looking for videos that help you remember this, I believe YouTube, if you just Google quadratic formula in Pop Goes the Weasel, you could probably find the song and the lyrics played out. So feel free to go check out that video. Now back to this problem here. So I've just found a, b, and c. So I'm ready to plug these values into my formula. Notice how x is going to be equal to negative b. So you have a negative in this formula, but then you're going to grab your b, plug it in, plus and minus the square root of b. So b is going to be 3 squared. So I'm going to put that in parentheses. Minus 4ac. So a here is 4, c here is negative 7. This is all going to be over 2a, and a here is a 4. So I got to plug in a 4. And then from here, you can see that you can try to simplify it, like maybe multiply the bottom out, maybe simplify the inside the root, and then keep simplifying until you can't. And so I'm not going to work out this problem fully because it's just asking me to set up to solve for x. But in the homework that I'm going to do here in the next slide, I am going to solve it out fully. So I'm going to start off with the page 4 on the packet, number 1. So if you want to turn to page 4 of your homework packet, I'm going to start out by doing problem 1. All right, so here I have a quadratic equation and it's in standard form. Notice how this side here is already 0. And so I can go ahead and figure out what my A, B, and C are. So A here looks like it's 1. It's a number in front of x squared. B here looks like it's a 2. C here looks like it's negative 8. And now I'm ready to use that quadratic formula. So just real quick, let me write the quadratic formula here. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And so I'm going to use this formula here to plug everything in. So I have negative 2 plus or minus the square root b squared, which is 2 squared, minus 4ac. So a is 1, c is negative 8, all over 2 times, well, a, which is 1. So all I have to do now is simplify. So maybe I'll multiply the bottom here, which would make it a 2 in the bottom. The top, I have a negative 2 plus or minus the square root. Let's clean up the square root here. So 2 squared gives me 4. Right? And then I have 3 terms to multiply. So let's multiply the numbers first. So 4 times 1 is 4. 4 times 8 gives me 32. But notice here there's a negative sign here and there's a negative sign here. So 2 negatives make a positive. And so from here, I just need to clean up this root. 4 plus 32 gives me 36, and I'm going to bring down the negative 2 and the 2 in the bottom. Now, the square root of 36 is a nice number. It's just 6. So I have plus or minus negative 2, 6 over 2. So remember, this here is my x value that I'm solving. So once I get down to, I got rid of the root, I can probably combine these numbers because they're all real numbers. But because I have a plus and minus, remember you have 2 equations. So I'm going to go ahead and split this up into 2 equations. So I have x equals negative 2 plus 6 over 2. And I have x equals negative 2 minus 6 over 2. So basically I just took that plus and minus and split them up so I can work it out a little bit more. So this top one here, negative 2 plus 6 gives me positive 4. Divide by 2 is 2. So x here is 2. The other one down below, negative 2 minus 6 is negative 8. Divide by 2 gives me negative 4. So it looks like the other x value is a negative 4. So we have solved for x. X is 2 and x is negative 4. And that's it. You have 2 x value, which you should. Since it's x squared, you should have 2 solutions. All right, so let's try out number 4 here next. Okay, so in number 4 here, we're going to try to solve it out, but first let's try to move that 2 over because this side's not 0. So I'm going to subtract 2 over, and that allows me to write this as 2x minus x minus 15. Negative 13 minus 2 is 15. And then this side's 0. So it looks like a here is going to be this 2. B here is negative 1, right? That's a negative x, so negative 1. C here is negative 15. So remember the formula that we're using is called the quadratic formula, and that's going to be negative b plus or minus the square root b squared minus 4ac all over 2a. And so if I was using this formula here, x is going to be equal to negative 1 because b here is negative 1. So that's 2 negatives that I need to be aware of. Plus or minus the square root. B squared is going to be negative 1 squared minus 4ac. A here is 2. C here is negative 15. 2 is going to be multiplied to 2 because that's going to be 2 times a. And so now I just have to clean this up. So those two negatives will make it a positive 1 plus or minus the square root. So negative 1 squared gives you 1. And then if I multiply this out, 4 times 2 gives me 8. 8 times 15. Well, let me just double check here with my calculator. Well, it looks like 8 times 15 gives you 120. Now, because I noticed there are two negative signs, that means it's going to be a positive 20 over 4. So this inside the root is going to be 1 plus 120, which is 121 over 4. 121 is a nice root. It's actually, if you take the square root of 121, you get 11. So you have 1 plus or minus 11 over 4. And so remember, this is your x value here you're solving for. So once you have some whole numbers, you can split this up into two equations. You can have x equals positive 1 plus 11 over 4, and x equals 1 minus 11 over 4. And so the top here is going to be 12 over 4, which is 3. So my first x value is 3. The top one here will be, the bottom one here, 1 minus 11 is negative 10 over 4. Now, negative 10 over 4 is reducible. So if you were to reduce this, a number that goes both into 10 and 4 is 2, right? Because 2 can go into 10 5 times. 2 can go into 4 2 times. So this is really written as negative 5 over 2. And I can't reduce this any further, so this here is my final answer. So it looks like x is equal to 3, and x is equal to negative 5 over 2, and that's it. All right, let's do one more practice problem together. Let's do number 6. All right, so for number 6 here, if I were to work this out, I need to try to get the 18 over to the other side so I can make this side 0. So let me just remove that first. So that cancels. I would have 8x squared minus 4x minus 18 equals 0. So my a here looks like it's 8. My b here looks like it's negative 4, and c is negative 18. So using that formula here, I need to plug in. Let me rewrite that formula here. You don't have to rewrite the formula. I just like to write it so that way I can see it as I'm plugging it in. So I have negative b, which is negative 4, plus or minus the square root of b squared, so that's going to be negative 4 squared, minus 4ac, so 8 times negative 18, over 2 times a, which is 8. So if I were to work this out here, these two negatives will make a positive 4 plus or minus the square root. Negative 4 squared is like negative 4 times negative 4, which is a positive 16. 4 times 8 times 18 gives me 4 times 8 times 16 is 576. So I'm adding that on. And then the bottom here, 2 times 8 gives me 16. So if I'm working this out, I just need to clean up this root here. So that's going to be 4 plus the square root. 16 plus 576 is 592 over 16. All right, so I need to take this root here for a moment and try to see if I can simplify that. So I know that it's an even number, so 2 will divide nicely. So if you divide it by 2, you get 296. And that's still an even number, so I know it divides by 2, which is 148. And that's still an even number, so I can still break it down by 2. So if I divide by 2, I get 74. If I divide by another 2, I get 37. Now, 37, I will say, doesn't break down, so it looks like you have a pair of 2's, and then a leftover 37, which means that these 2 here, 2 can come out of the root, and then another 2 can come out of the root. So you have 4, because 2 times another pair of 2's is 4, And then the leftover here is the 37, so that goes back in the root. So this really is 4 plus or minus 4 square root of 37 divided by 16. Now, if you wanted to simplify this problem even more, you can put each of the terms in the top and divide it by 16. So if you were to do that, you will notice that this reduce as 1 over 4, and this one here as, well, this would cancel, and that'd be a 1, that would be a 4. That would be a 4. So this would be square root of 37 over 4. And I can't combine that because that's a root and that's a number. So I'll just leave my answer like this. And so, oh, hang on, I forgot something here. I forgot the plus and minus. So let's add that on there. And so looks like x is equal to plus or minus, x is equal to 1/4 plus or minus the square root of 37 over 4. So you can write your answer like this. Some people even write it as like x equals 1 plus the square root of 37 over 4 as one denominator. You could do that. There's multiple ways you can write it. I keep forgetting the minus sign. There's a minus sign, guys. All right, and that's it for this journal.